Hello and welcome friends. In this particular module, we wish to discuss about the characteristic of the contour and methods of contouring usually employed in land surveying. The content is in line with our earlier presentation, which is dealing with fundamentals of contouring. In this particular presentation, we will get acquainted with these characteristic of the contours as well as direct method of contouring, indirect contouring methods such as block, grid, squares, cross sections, tachometric, and based on control points. We will also discuss some things which will highlight the basic differences in direct and indirect contouring methods. As you learn this particular content, you will be able to define and represent certain land features having knowledge of characteristic of the contours, as well as you will be able to carry out the field work for contouring by direct and indirect methods. Let's have some brief recap over the discussion that we had earlier. Contour is nothing but the line which is joining the points of equal elevation. The map which shows various contour lines is called as contour map. The contour map is essentially used to know the nature of the terrain, to locate the physical features, to select the suitable site for desired engineering project, to locate the alignment of engineering structures, and to decide the formation level. The vertical ordinate in between two successive contours is called as contour interval, and it has to be constant for a given contour map. The value of this particular contour interval may vary according to the nature of the terrain, the purpose and extent of the survey, the scale of the map, as well as time and expenses related with field and office work. For certain category of the works, the guide values are available which could be ranging right from 0.2 meter to even 25 meter, the way we discussed in our earlier presentation. The knowledge of this particular characteristic of the contouring is very much essential to read the toposheets which are readily available, as well as to construct certain toposheets in order to represent various land features. So, we'll discuss now about the characteristic of the contour. As we know, all the points on the contour line are having the same elevation. Let's take a reference to this particular sketch. The way you see here in this particular sketch, the contours are placed almost parallel to each other and they are straight line form. Wherever we see some such structure, we can interpret that the ground is plane surface. On the similar terms, here contours may not be exactly parallel to each other or may not be horizontal, but more or less they will be attaining the same shape as that of this particular plane surface, and they will be representing certain uniform slope. As they come closer, they will be presenting some gentle slope. Whereas when the contours are placed very close to each other, they will be representing some broken ground, and the ground under consideration being shown would be of steep slope nature. Also, as you see here in this particular contour map, the contours are forming certain loops and they are giving some typical intervals here. So the way you see, the innermost contour has got lowest reduced level as well as the outermost contour has got highest value. So typically, whenever we are dealing with some depression, whenever we are dealing with some structure like depression, it will be represented by this particular form. Whereas, as you see on the lower side, here the outermost contour has got least value, and on the contrary, the innermost contour has got highest value. As such, the structure represented here is kind of hill. So, the way I discussed on the previous slide, here you can have the idea very clear related with the nature of the contour loops representing some depression. We can consider typically some structures like ridge as well as valley in order to represent topographical features. So the way you see here, this particular innermost contour is having higher value as compared to the outermost contour. Here, at this particular dotted line, the contours are almost perpendicular to that particular dotted line. So under such circumstances, the feature represented is ridge line. Whereas in the case is just reverse. That is, here the way you see, the contour placed at the innermost has got lower value, whereas the contour which is placed at the outer end has got higher value. Here, this dotted line will be giving the valley line. Usually, this particular valley line can also be correlated with probable stream existing in that particular region. Here also, one can make out easily. In the earlier presentation, we discussed about the contour as an outcome of intersection of the level surface and the feature under consideration. Hence, the way you see the presentation of the contours, it is in 2D form, but in reality we are trying to represent even the relief in the vertical plane. So because of the limitation of that particular say presentation, we are presenting in this particular 2D form. But the way you see here, we wish to present all these particular points placed one above other by making use of this number of contour loops. Here at this particular point, as you see, the innermost contour will be representing the topmost point, whereas as we consider the lowest point in that particular order, it will be having lowest value as such. But in vertical plane, they will be attaining the same position. So here, though these particular contours are getting overlapping at each of this particular point. These are indicating some different positions as indicated in the vertical plane. So here these will be indicating some cliff-like feature. Whereas in reality, contour won't intersect each other. Essentially, they form a closed loop, not necessarily within the margins of the topo sheet that we prepare. But the way you see here, the contours are intersecting each other as well as they are overlapping each other for some cases. So here typically, as you see, this is some overhang of that particular mountain, and here in order to present that upper point and in order to present that particular lower point, here we have taken the two contours which are placed with a vertical ordinate of 200 and 250 meters above the data. So for certain features like cave, for certain features like overhang, the contours would be crossing each other, whereas for cliff-like feature, they will be simply overlapping each other. The contours can be constructed by making use of two methods. The first method is termed as direct method, whereas the second one is indirect method. We will discuss about these particular methods as we move to our next slide. See here, this particular blue portion is indicating some, say, top of the plane table. For time being, we will consider. Here we have placed some equipment which is helping us to sight various stations. Thereby, here actual height of equipment attained is of 100 meters. Say now, we wish to plot certain contour which is having reduced level of 90 meters actually on the ground. So as you have knowledge of leveling operations and reducing the reduced levels, so in order to have the reduced level of station as 99 meters, the stop reading read should be of 1 meter. So thereby, here what we can do is, the person who is attaining this particular instrument position will be instructing some staff man in order to move in such a manner that he will be able to have the reading of 1 meter. As at this particular end, reading is obtained as 1 meter, he will instruct that particular staff man to drive a peg. And now the staff man will move to the next point. The procedure that is followed at this particular point would also be followed at each of such points in order to have different peg positions which will be indicating the reduced level of 99 meters. Now as we do so, here by making use of construction of height, we can actually draw this particular contour on site. So as this particular contour is actually traced on the field, subsequently or even simultaneously, you can make use of other method in order to plot the position of this particular traced contour on the ground. So here one can make use of some, say, theodolite traverse, one can make use of plane tabling, one can make use of simple offsetting technique. Say for example, here we can take reference of line AB, we can take reference line, say BC. So with respect to BC line, in order to locate this station, simply this x coordinate and y coordinate is enough as far as the location of this particular point. So here we will be following our second principle of surveying. We will be making use of two independent measurements in order to plot that particular locations. So thereby this particular direct method is helping us to trace the contour actually on the site as well as simultaneous plotting of the same by making use of some other convenient surveying technique. So here the procedure that I discussed in earlier slide is given here for your reference. It may be noted that the surveying party will be dealing with one contour at a time. Once one contour is plotted, when its position is assessed, then one can move to next value from the same instrument station or otherwise shifted instrument station. Indirect method is the method which takes the reference of some network of survey lines laid over the area under consideration. Here, the spot levels of several representative points representing various land features are taken into account and plotted with reference to the network of the survey lines as one comes to the office. This particular method is not as accurate as direct method, because in direct method we were able to assess the existing land feature with the way we wish to represent it by making use of the contour line. But here what is happening? We'll be making use of network of the lines with reference to which we'll be plotting the various features as a part of office work. As we move ahead, the concept will be more clear to you. As compared to direct method, this method is rapid, less tedious, even cost-wise it is cheaper, it is suitable for certain broken grounds where undulations are much in the form of certain hilly area. We need not do the calculations on the site. Once that particular network is drawn on that particular ground, we do not need any kind of the calculations. But we do have the freedom to calculate and apply the check in field as well as in office as and when required. So here you can see actually this particular reference network in the form of these squares or grid or the blocks is prepared on the site. Now our job is to have the equipment position conveniently placed so that each of these particular section referred and its reduced level will be assigned. So just for example, say here if this particular line is giving some say change of 100 meters, let me consider this point as say 100. So 100, left 10, left 20, left 30, left 40. So all that particular reduced levels will be actually determined. Say if we are having the interval or this particular model size of 20 meter by 20 meter, so accordingly here what will be happening now? At this particular point, say it will be 120, so 120, left 10, left 20, left 30, left 40. So as such, we will be having our page book ready in the field book showing all that particular reduced level. Now, as we come to office, we will be reproducing this particular network of survey lines with reference to the actual meridian, and accordingly by following certain scale will be having each of these particular section defined on the drawing sheet that we wish to prepare in the form of that particular contour map. So at each of these particular sections now, the way you see, we can diagonally write all that particular reduced levels. Now we have to take a reference of the all such entered values, and now we can make use of simple similar triangle principle in order to know the intermediates to assign the respective reduced level. This particular method is called as method of squares, grid or the block, as these particular values are to be used as reference values and they are to be further used in order to determine the reduced level of certain intermediate virtual points. The process is called as interpolation of contours. More about this particular interpolation we'll discuss in our subsequent presentation. Sometimes we may deal with certain, say, road-like narrow strip. So the way you see here, this is particular center line, which is for a certain road-like feature. So with respect to that, we can have, say, C0, L10, L20, C0, R10, R20. Similarly here, for say that particular cross section of 840, here it will be C0, L10, L20 and accordingly. So here we are taking kind of cross sections placed at 20 meter perpendicular to that particular center line of the feature under consideration. Now we did not have all that particular cross section at 90 degrees itself, because as you know, as we deal with certain pipeline like structure, as we deal with certain road like structure, as we deal with certain canal like structure, there will be number of turns that would be involved, and accordingly here these particular lines will be perpendicular sometimes, or it could be, say, making some convenient angle in order to plot the feature under consideration. We are expected to have the reduced level determined at each of these particular cross sections, but sometimes if there is some feature which is placed intermediately which could be affecting the estimation, subsequently we can catch its location and accordingly we can determine its reduced level also. One more method is tachometric method. So the way you see here, we are making use of tachometer which is placed at the center, and now instead of making use of certain regular squares or regular rectangles, here we are making use of certain radials placed at some convenient angular interval. So with respect to that particular station, now we can have, say here if this is 0 degree, so C0, 0.1, 0.2, 0.3, 0.4. So just one can follow some convenient marking of that particular stations, and accordingly one can determine the reduced level. So here this particular network can also be reproduced on the plane sheet, and accordingly here we will be making use of two values, two reduced levels in order to interpolate that particular contour. Here as we discuss about the tachometric technique, once again we will discuss about this particular contouring method. Sometimes we can go for certain significant points. So the way you see here, this particular bluish dots are showing the typical change in the direction of that particular contour. So here we can make use of these particular control points, key points, and we will be simply determining their position and their reduced level. So as we come to office, we can make use of simply these particular control points in order to interpolate these particular contours. So here this is kind of say golden mean of direct method and indirect method. The method is approximate, but it is quick. It facilitates the good results, and that's why this particular method is adopted when the ground is uniformly sloping and we wish to have reconnaissance done in short period of time. So thank you for your attention. I hope all the points that we try to discuss in this particular presentation are clear to you. You may give me your feedback. You can post your doubts. In next presentation, we'll be dealing with interpolation of the contours as well as some specific cases related with contouring operations. So bye till then. I wish you very happy learning. Thank you. Thank you very much.